In this mini-lecture, which is part 1 of the mini-lecture on air pollution, we will discuss the structure, composition and function of the atmosphere, air pollution, and the effects of air pollution. After reading chapter 17 and watching this video or reading the transcript that goes with this video, you should be able to describe composition, structure and function of Earth's atmosphere, relate weather and climate to atmospheric conditions, and identify major pollutants, outline the scope of air pollution, and assess solutions. We are intimately connected to our atmosphere, or the thin layer of gases that surrounds Earth. The atmosphere provides essential ecosystem services such as climate regulation, oxygen for respiration, protection from harmful ultraviolet radiation, and cycling and transporting water and nutrients essential for life on Earth. The atmosphere is stratified in several layers, each with distinct properties. The figure on the left is figure 17.2 from your book. The red line indicates the temperature in each of the layers of the atmosphere. Beginning with the layer closest to us, and which we live in, the layers are the troposphere, stratosphere, mesosphere, and thermosphere. Also notice that the tropopause separates the troposphere from the stratosphere. I've included an image in the bottom right that should help you visualize each zone and which provides a point of reference in terms of what human or natural objects or events you might find in each zone of the atmosphere. Temperature fluctuates in each of the layers of the atmosphere. In the troposphere and mesosphere, the temperature decreases with increasing altitude, but in the stratosphere and the thermosphere the temperature increases with increasing altitude. The troposphere is the layer of the atmosphere in which we live and interact. This layer contains the air we breathe and drives the weather patterns of the planet. Notice the greatest concentration of atmospheric ozone is in the stratosphere. For your information, ozone is O3, meaning ozone is 3 atoms of oxygen bonded together. This is where the Earth's protective ozone layer is located. Please note that the stratosphere is far above where we live. The ozone layer is a layer of ozone gas that absorbs and dissipates ultraviolet, or UV, radiation from the sun. Without this layer, we would be exposed to harmful radiation that cause mutations and which damage living tissue. The Earth's atmosphere is composed largely of nitrogen, oxygen, and argon, with nitrogen comprising 78% of the atmosphere, oxygen comprising nearly 21% and argon a little less than 1%. There are a variety of other gases in the atmosphere, however they are at far lower concentrations, with the exception of water vapor, which varies in concentration from 0 to 4%. Air pollution can come from both natural and anthropocentric sources. Air pollutants are defined as gases and particulate material added to the atmosphere. These pollutants can affect climate or harm people or other organisms. Air pollution is the release of air pollutants. Natural sources of air pollution include fires, which generate soot and gases; wind or dust storms that send huge amounts of dust aloft. Windstorms can be so powerful that they can carry dust across oceans. Finally, volcanoes can release particulate matter and sulfur dioxide into the atmosphere. By far, the amount of air pollution from an anthropogenic source greatly exceeds natural-sourced air pollution. Just as with water pollution can be categorized as point or non-point source. Point source air pollution is air pollution from specific spots where large quantities of pollutants are discharged. A prime example of this type of pollution is a smokestack from an industry factory. Non-point source air pollution is air pollution that is more diffuse, consisting of many small, widely spread sources. Good examples of non-point source include emissions from planes, trains, and cars. A good way to keep these two categories of pollution straight in your mind is to think that for point source pollution you can physically point to the source and say, that is the source of the air pollution, whereas with non-point source pollution you cannot point at one single source because with non-point source pollution there are many, small and geographically spread out sources contributing to the pollution problem. This analogy works for water point and non-point source pollution as well. Air pollutants can also be categorized as either primary pollutants or secondary pollutants. Primary pollutants are pollutants that are directly harmful or can react to form harmful substances, such as carbon monoxide and soot. Secondary pollutants are pollutants that form when primary pollutants react with constituents of the atmosphere. A good example of this type of pollutant is tropospheric ozone, which is ozone that is in the troposphere, not the stratosphere. In the US and other developed countries, relatively recent legislation, such as the Clean Air Act of 1970, and improved technologies have helped to reduce most types of outdoor air pollution, which is also called ambient pollution. However, developing countries and urban areas still have significant problems with ambient air pollution. One of the worst types of air pollution may be greenhouse gases. We will discuss greenhouse gases in detail in the global climate change lesson. Air pollutants vary in their residence time, which is the amount of time they linger in the atmosphere. For example, particulate matter in car exhaust stays aloft for hours or days. This is why air quality in a city can change from day to day. On the other hand, pollutants with long residence time persist in the atmosphere for longer, that is weeks, months, years, decades or even centuries. Pollutants with brief residence times, hours or days, exert localized impacts over short time periods. Pollutants with longer residence times, such as greenhouse gases and chlorofluorocarbons, have regional or global impacts and exert these impacts for decades or centuries. State and local agencies monitor and report to the Environmental Protection Agency, or EPA, emissions of carbon monoxide, sulfur dioxide, all nitrogen oxides, volatile organic compounds, particulate matter, and lead. Volatile organic compounds, or VOCs, are carbon-containing chemicals that have a high vapor pressure at normal room temperature. This means that VOCs volatilize or transform from a liquid or solid to a gas very easily at room temperature. We will explore VOCs more later in this mini-lecture. Several of the previously listed compounds are considered criteria pollutants, which are pollutants that are regulated by the EPA. The 6 common air pollutants classified as criteria pollutants are carbon monoxide, sulfur dioxide, nitrogen oxides, ground-level ozone, also known as tropospheric ozone, particulate matter, and lead. The EPA sets standards for emissions of criteria pollutants called National Ambient Air Quality Standards, NAAQS. In 2012, the D.C. Court of Appeals ruled that the EPA has the authority to regulate another key atmospheric pollutant, carbon dioxide. This puts an end to a long-standing suit that challenged the EPA's findings that this pollutant endangered human health and should be regulated. Criteria pollutants are judged to be especially dangerous to human health. It is estimated that 127 million Americans live in areas that violate at least one criteria pollutant during a portion of the year. We will now examine each of these pollutants individually. Carbon monoxide is a colorless, odorless gas formed by the incomplete combustion of any organic fuel. The primary source of carbon monoxide is motor vehicles. Industry, waste combustions, and residential wood burning account for a smaller portion. The source of this pollutant. Carbon monoxide is a very dangerous gas because it binds to hemoglobin and reduces the amount of oxygen delivered to tissues and organs, especially heart and brain. People who have carbon monoxide poisoning can easily die of asphyxiation. This is why you should never run your car in a garage with the garage door closed and why you should never operate a generator inside your home. If you have natural gas in your house as a source of energy, install, maintain, and check a carbon monoxide detector. Sulfur dioxide is also a colorless gas, but unlike carbon monoxide, sulfur dioxide has a very strong and distinctive odor. Sulfur dioxide smells like rotten eggs. The main sources contributing to sulfur dioxide emissions are coal-fired power plants and industrial fuel combustion. Sulfur dioxide gas causes respiratory and cardiac illnesses, haze in cities, acid deposition, and interferes with photosynthesis. Acid deposition, commonly referred to as acid rain, is any precipitation that is usually acidic. Acid rain can harm both natural systems and man-made structures. The image seen here is a statue before and after it was subjected to acid rain. As you can see, the acid rain ate away at the features of the statue and left it significantly marred. Nitrous oxides are symbolized using a capital N, followed by capital O, followed by a subscript X. Nitrous oxide is the general term for compounds with nitrogen and oxygen. As the symbolized name denotes, nitrous oxides can vary in the number of nitrogen atoms found in the atom of the compound. Nitrous oxides come from motor vehicles, utilities, and industrial combustion and cause a variety of effects including smog, which is red-brown haze, acid rain, damage to buildings and cars, damage or death to aquatic life, eutrophication, and damage the lungs of mammals. Finally, nitrous oxides contribute to ground-level ozone. The image in this slide shows smog over a city. Smog is in large part caused by the nitrous oxides emitted by motor vehicles. Tropospheric ozone, also known as ground-level ozone, is a secondary pollutant formed when the heat from sunlight transforms nitrous oxides and VOCs into ozone. For this reason, tropospheric ozone has no direct emissions to monitor. Keep in mind that ozone in the stratosphere is protective and beneficial, however ozone in the troposphere is harmful and destructive. This is also the pollutant that most frequently exceeds EPA standards. Tropospheric ozone is also a major component of smog. This pollutant harms living tissues and causes respiratory problems. If you have ever lived or visited in a city during the summer, you have likely heard or seen an ozone alert. Most major cities have ozone alerts during the summers because this is the warmest part of the year and the heat combined with the emissions from vehicles produces harmful ground-level ozone. Particulate matter, abbreviated PM, is a pollutant that consists of particles that come in many sizes and shapes and can be made up of hundreds of different chemicals. Some particles, known as primary particles, are emitted directly from a source, such as dust or soot from construction sites, unpaved roads, fields, smokestacks or fires. Others form in complicated reactions in the atmosphere of chemicals such as sulfur dioxides and nitrogen oxides that are emitted from power plants, industries and automobiles. These particles, known as secondary particles, make up most of the fine particle pollution in the country. Particulate matter can either be suspended solids or liquid particles. When inhaled, these particles damage respiratory tissue when inhaled. The figure in this slide provides you a point of reference for the size of particulate matter. Particulate matter is classified as either PM10 or PM2.5. Dust, pollen, mold and other similarly sized particles that are less than 10 microns in diameter but greater than 2.5 microns in diameter are classified as PM10. Particles from combustion, organic compounds, and metals that are less than 2.5 microns in diameter are classified as PM2.5. Lead is a heavy metal that enters the atmosphere as a particulate pollutant. Lead was once found in gasoline in developed countries because it kept the engines running smoothly and prevented the engine from knocking. However, lead was phased out of gasoline in most developed countries, including the U.S., in the 1990s because it was discovered that burning leaded gas emits airborne lead that can be inhaled. Lead can also get into food and drinking water because the lead can be deposited on the ground and in water. Lead bioaccumulates in organisms and acts as a neurotoxin, which means it attacks the central nervous system. Infants and children, whose brains are developing, are especially susceptible to lead-induced health effects. Developing countries largely still have lead in their gasoline. Despite the phase-out of lead from gasoline, lead is still emitted into the atmosphere in developed countries by industrial metal smelting. Though not a criteria pollutant, local agencies monitor and report data on VOCs to the EPA. VOCs are found in a variety of everyday commercial products including paints and paint strippers, cleaning supplies, pesticides, copiers and printers, correction fluids, glues and adhesives, permanent markers, and dry clean clothing. Engines can also emit VOCs. VOCs can be both an indoor and outdoor pollutant, however levels can be 10 times higher in indoors than outdoors. The health effects of VOCs include eye, nose, and throat irritation, headaches, loss of coordination, nausea, and damage to liver, kidney, and central nervous system. Additionally, Some VOCs carcinogenic. Key signs or symptoms associated with exposure to VOCs include eye irritation, nose and throat discomfort, headache, allergic skin reaction, shortness of breath, nausea, vomiting, nosebleeds, fatigue, and dizziness. If you've ever painted a room that wasn't well ventilated, you've probably been exposed to VOCs. Also, that new car smell everyone loves so much, that is caused by VOCs as well. If you think you've been exposed or are being exposed to VOCs, get fresh air, and if your symptoms persist, seek immediate medical attention. Also, recall that VOCs can react to produce tropospheric ozone. That concludes this mini lecture on Part 1 of Atmospheric Science, Air Quality, and Pollution Control. If you haven't done so already, please watch Part 2. Please review the weekly outline and complete the activities for this week per the schedule set forth in the outline.